Okay, who would like to come up here and share their work and answer? Aaron. You'll be fine. Is your work matching his? You know what, Aaron, go ahead and leave the denominator factored. Okay. Okay, so Aaron has 7x squared plus 4x minus 4 all over x times x plus 2 times x minus 2. Do you agree?
Yes.
Okay. What Aaron did, okay, I'm assuming that this means you multiplied both top and bottom by x plus 2 times x minus 2. Okay, he figured out that our common denominator needed to be x times x plus 2 times x minus 2. Okay, so he multiplied each fraction by whatever the denominator didn't have, both numerator and denominator, okay, to get to here, and then simplified it to here. Okay. Does everyone remember doing that last year in Algebra 2?
So he wants the answers back.
The denominator should be factored. The numerator you'd want to add like terms, and then if you can factor it to cancel anything out, you can. Okay. All right, I'll go ahead and collect those. We will talk about your quiz at the end of class. Okay. Today we are going to be dealing with partial fractions, which is basically the complete backwards steps than what we just did. Okay.
I think he'll go with it all.
up, I had you take three fractions that were added together and I made you condense it into one fraction. Today and tomorrow we're going to take one fraction and we're going to break it apart into two or more fractions. Okay? This is called partial fraction decomposition. Okay? We're taking a fraction and we're decomposing it. We're breaking it up. Okay? We are going to learn about the setup today and actually do the algebraic work tomorrow. Okay? Don't want to overwhelm you all in one day, so we're going to learn how to set up each problem, and then tomorrow we'll talk about how to actually solve it. Okay? So, like I said, partial fraction decomposition is the reverse of adding rational expressions. This is a technique that will be valuable in calculus if any of you decide to go in that direction. Okay. So what we are going to do, okay, we have one fraction that we're going to break apart. Okay. Back to my warm-up. What do you notice? Okay, so we're starting right here with the answer and we're going to work our way to here. Okay, what do you notice about this denominator compared to our beginning problem? Okay, all of these factors, there's one fraction for each of them, right? Okay. So what we're going to do in order to start here and work our way backwards, we are going to need to factor the denominator. Okay? That way we know how many fractions it's going to be broken up into and what the denominator for each fraction is going to be. However many factors there are, that will be how many fractions we break apart into. Okay? So in our warm-up, if we were going backwards, there are three factors, so we broke it apart into three fractions. Okay? Now, today, we're going to write our problem. Okay? So we're going to take our factor denominators, okay, and we're going to write a fraction for each of those with a variable on top. All right. Let me come back here. So I'm going to be flipping back and forth a little bit. Notice how these linear factors in the numerator all have constants. Okay, so we're going to call those like A, B, C, D, and that's what we're eventually going to be solving for. Okay? So we're going to write out our problem with variables on top for what we're going to be solving for. Okay? If there is a repeated factor, for example, if we had x plus 1, the quantity squared, as a part of our denominator, then we would need a fraction with x plus 1, and we would need a fraction with x plus 1 squared. We have to account for it being repeated however many times. Okay? So if you have a repeated factor, you have to include lesser powers of that factor to account for it happening that many times. Okay? Now, when we have linear factors, when we break it apart, our numerator with that linear factor is going to be a constant. However, is every quadratic factorable? No. So if we have a quadratic as a factor in our denominator, then our numerator is going to be a linear function. right? So if we factor out our denominator and one of our factors is quadratic, when we write out our separate fractions, the one with the quadratic in the denominator, the numerator is going to be some sort of linear function that we'll have to solve for. Okay? And of course, this is going to make more sense as we set up our examples. Okay? So once we do examples and you look back at this, okay, it'll make a bigger connection. Alright? There's two more steps on here, but they're about solving, which we're going to talk about tomorrow. Okay. So, here's our first example. Please write it down. First step was to factor the denominator. What does our denominator factor to? Okay. How many fractions are we going to break this apart into? Two. There are two factors in my denominator, so we're going to break it apart into two fractions. So we know that x plus 7 over x minus 3 times x plus 2. Sorry, I'm going to run out of room, so I'm going to write it down here. We know it's going to equal the sum of two fractions, where one of them has a denominator of x plus 3, one of them has a denominator of x plus 2. Okay? Now, these are linear denominators, correct? So there's going to be some constant in the numerator, a and b. Okay? You don't want to name them x and y. Okay, that's not going to help. Right? So I'm going to use capital letters starting with a when I do this. Okay? They just stand for constants, and a and b are more times than not different. Okay? This is all we're going to worry about today. Tomorrow, I will teach you how to actually find a and b. But right now, we're just worrying about setting it up. We have two factors, so we broke it apart into two fractions. Everyone okay with that? All right.
That's all we're doing.
Yes.
I'm on the board.
All right, first step. Factor the denominator. What does the denominator factor to? Difference of squares. X plus 2 times x minus 2. How many factors do we have? 2. So how many fractions are we going to decompose this into? 2. Each fraction represented with each of these factors for a denominator. Our denominators are linear, which means the numerators are going to be a constant. We'll name them a and b.
How do you know it's addition?
We'll say it's addition, and then if b ends up being negative, we'll write it as a subtraction. Does that make sense? Okay. Now let's talk about how we would get from here to here. Okay. If you were given a over x plus 2 plus b over x minus 2, all right, you'd want a common denominator, so you can multiply this second one by x plus 2 over x plus 2, multiply this first one by x minus 2 over x minus 2, and we can switch it back to one fraction, right? Okay, so we'll use that a little bit tomorrow. Okay, let's step it up a notch.
Your choice.
Okay, we need to factor the denominator. Don't factor the numerator. What do we need to do first?
Factor out an x.
Factor out an x. Then what? Does that trinomial factor? X plus 1, the quantity squared. Okay? This is not a quadratic factor. It is a repeated linear factor. We have the same linear factor happening twice. Okay? So technically, how many factors do we have in this denominator? We have 3. So we're going to break this apart into 3 fractions. Okay? One of them is going to have a denominator of x. Now, x plus 1 is happening twice, and we have to account for that in our fraction. So in this fraction, I'm going to write x plus 1. And then in the last fraction, I'm going to write x plus 1, the quantity squared. No. Because if it was x plus 1, I'd be able to just add these two together, and we never get that x plus 1 squared. Does that make sense? Okay. Let me come over here. Let me make up some numbers, okay? You know what I should probably do. I'm just making up numbers. These aren't actually going to be what's... Okay, so Katie wants this last one to just be x plus 1. But since these two have the same denominator, couldn't we combine them together? And if I try to add these two, we're never going to get that x plus 1 squared represented. Okay? So, anytime you have a repeated factor, you need that and all the lesser powers. Okay? So we have the x plus 1 squared and the x plus 1 to the first. Okay? These are all still linear, and so our numerators are still constant.
So let's say the x plus 1 was cubed, and you have an x plus 1 squared and an x plus 1 cubed, and then how would you write the constant on top? And you still just write it as b?
Yeah, right. If this was x plus 1 cubed, you'd need all of these and a d over x plus 1 cubed. All 3 would have to be represented.
So variables don't ever get raised to like just like a letter.
Right. Yeah, these just represent constants. Other questions about this equation? This one. What does our denominator factor to? Can x squared plus 1 be factored? No. So how many factors do we have? We have 2. X and x squared plus 2. Right? No. We have 2 factors, so we're going to have 2 fractions. Now, x is a linear factor, and so we're going to have a constant upstairs. X squared plus 1 is a quadratic, and so its numerator is going to have to be linear. Okay? You can't just write bx. It has to be bx plus c. Okay? A linear equation could have a constant with it.
That's what I was thinking for the cube denominator, but like but it's not.
But it has to be like x.
It wasn't quarters, yeah.
Correct. There's a big difference between a repeated factor and a quadratic factor. Okay, let's look at the difference. This is a quadratic factor. This is a repeated linear factor. It's a linear factor that's happening more than once. This cannot be factored. It's just a quadratic. Okay? Can everybody see the difference? Last one. Maybe I'll let you try this before we go through it together.
That's fancy. Picnic puts the because he's got it and so he's
49% sure it's right, 6%.
49% should. Right.
Just a guess. Well, it's my guess.
just trying to use
Yeah, screw it up.
Raise your hand if there are two fractions. 3 fractions. And a little bit of a disagreement here.
Why was actually
Okay? What does the denominator factor to? Okay. Be careful. X squared. Is it a repeated linear factor or is it quadratic? It is a repeated linear factor. Y equals X is a linear function. And so X squared is a repeated linear factor. No. That is a great question. Okay? This is linear. It gets a constant. X squared is a repeated linear factor, and so it still has a constant upstairs. And this
Way off.
what? When you have a quadratic factor. This was a quadratic factor. It had a linear upstairs. Okay? This is a repeated linear factor, so it gets a constant upstairs. Okay? That's probably going to be the most confusing thing about this, which is why I want to take today and just set these up.
So why would you do X plus 2? Just because
This is a quadratic
or
factor.
it's just like just any linear equation right now.
Right. We made it generic, and then we'll solve for B and C tomorrow. Okay? Okay, so what I'm going to do is I'm going to write your homework up here, but I want to go over the quiz. All right? So write this down while I hand out the quizzes. Aaron and Nick and Jacob, write it down, and yes.